Okay, question 3. So here we've got ball A is projected vertical upwards at a velocity of 20 meters per second from the ground. Then on its way down, it passes point P with a speed of 6.87 meters per second. Then ignore the effects of friction. Okay, and then we can see this diagram here. This is the path that is followed by the ball, or ball A. So now the first question is asking us to define the term projectile. Okay, so now for projectile, for all definitions, you should always follow your exam guidelines, okay, so that you don't get it wrong. So what are we talking about here? So we're talking about an object upon which the only force that is acting is the force of gravity, or gravitational force. Okay, that's number one. So but then you're going to write it as is from your exam guideline. Okay, so this here, the only force that is acting on it is the force of gravity. Okay, cool. Then let's then look at a second question, 3.2. They're saying here, using equations of motions only, calculate the time taken for ball A to reach point P. Okay, for ball A to reach point P on its way down. Okay, so how do you then do this one? 3.2.1. Okay, so from the statement, what we have here, so we've got your initial velocity, which is your 20 meters per second. You also have your, this is the velocity when you get here, the 6.87. But now what you need to do is you're looking for time, which is a delta t here. Okay, so when you're doing this, you just need to check your equations of motion, or use the equations of motion that has time. And the easiest one that we've got here is, you can say Vf equals to Vi plus A times time. Okay, why are we using this one? It's because we've got the final one when we get here, which is 6.87, and then from here, this point, we had 20 meters per second. Okay, that's one thing. Then again, what we need to choose is going up, we choose as positive, down as negative. Okay, you need to choose a direction. Right, so now if I'm choosing up as positive, that means when the ball is going up, I'm going to have a positive velocity, which is your 20. So that means here you're going to have 20 meters per second, because we're going up. And then not this one, this is final is 6.87. so 6.87 is when the ball is going down. So that means here is going to be minus 6.87, because the ball is going down and it's taken down as negative. And then when it was going up, which is our initial velocity, we had a 20, right? And then plus acceleration here is always going to be going downwards. Okay, it's always going to be going downwards. So that means it's going to be minus 9.8 meters per second, then times the delta t. Okay, then this is what you have now. So you're just going to then transpose this, take 20 to the other side. So then you're going to have minus 26.87. This is going to be minus 26.87 equals to minus 9.8 delta t. So then you're going to just divide both sides, okay, by minus 9.8. Then minus 9.8. So then you're going to have the delta t as what? You're going to get your 2.74 seconds. Okay, so this was just free marks for you. Okay, this is free marks. Then when you go to the next question here, they're asking us to calculate the height of point P above the ground. Okay, so point P, you can do it in two ways. Okay, but you can take the easiest one for you, okay, or the one that works best. But I think here I can give you both solutions. So I'm going to say 3.2.2. So one of them, like what I can do here is I can come here and then use this formula here. Say VF squared VI squared plus 2A delta Y. Okay, but now this is going to give me what? So what I can do here is I've got 20 meters per second at this point here, and then the ball moves, then gets to this maximum here, and then at this maximum height we know that v at this point is going to 0 meters per second. So I can calculate that point first, okay, and then I come back, I calculate this distance from here at the peak to P. I can also calculate that because I'm also going to have my velocity here is going to be your 6.87, and then I can subtract these two heights. Okay, let me just show you how it goes. So right now I'm going to calculate to the maximum. So the maximum I set here is going to be 0, your VF for your maximum height, going to be 0, and then the initial one that we had was 20 squared, then plus 2. We said down is negative, so it's always going to be minus 9.8, then delta T. This is what you have, okay? And then I can punch my calculator here and see what do I get. So I can have 19.6 delta Y equals to 20 squared, and then divide by your 19.6. Okay, then what do we get here? What is our answer? So then I have my 20.41 meters. Okay, but now this is not the final answer. Don't let it confuse you. This 20 here is until here. So from this ground until that point, you're going to have this 20 meters. Okay, this distance here is going to be 20. Then now that means we need to then calculate from this point here to P, right? So we can then do like so. Let's use another color. So you can say this again. So you can say VF squared again, VI squared plus 2A delta Y. Okay, so now we are calculating from the peak, right? From the peak like so, to point P. So this is your peak here. This is your peak where V is equals to 0. Then this is your point P here. Okay, where your velocity is equals to 6.87. So here the final velocity is going to be 6.87. It's actually minus 6.87 squared equals to the initial velocity, because we're starting at the peak, going to be 0 squared, then plus 2 minus 9.8 delta Y. This is what you have. Okay, and then you then punch your calculator. Let me see, what do I get? So here it's going to be 87 squared equals 2 minus 19.6 delta Y. And then divide both sides. 10.6 19.6. Okay, so this is where we are now, right? So then from my calculator I'm getting minus 2.4, okay, meters. So what this here is telling me that it's 2.4 going down. Okay, so if I were to draw this for you, I would have this part going to the peak, and then from the peak going to point P. Okay, so how then this is going to be? This is going to be a 20 meters going up, right, until here. So from the ground until there is 20, and then from this point until here, point P, you're going to then have this 2.4. Okay, so that means your final answer is going to be delta Y is equal to this 20 minus 2.4 here. So this was 20.41 minus 2.4. Okay, and then you're going to get an 18 here. 18 meters. Okay, this is what you get. Then again, you can use the other formula, which is I'm going to give you as option 2. Okay, now for option 2, this is your easiest way out. But now, this was just so that you understand what you're doing here. Okay, so let's go for option 2 and see. Okay, so for option 2 here, you can use your famous formula here that most people like. And have VI delta T plus 1 over 2 A delta T squared. You can use this one. Okay, it's your easiest way out, but for your own understanding, that's why I'm doing both of them. So you're then gonna have the delta Y equals to V initial is going to be your 20 meters per second because it's moving from the ground. And then we calculated time here, our delta T. Okay, remember this was the time to reach point P, right? So use your 2.74. So that means you do have the time it took the ball to reach point P. You're gonna have 2.74, then plus 1 over 2. This is gonna be minus 9.8. And then 2.74 again, then squared. This is what you have. So you can see this is your easiest way out, and then this would have saved you a lot of time. Okay, then you can punch your calculator, and then you're going to get the same answer here. Okay, it's going to be your 18 meters again. So you can see I just wrote like 3 lines as compared to this. Okay, but now you understand better. That's great. So then let's look at the next question. What are they asking us here? So here they are saying when ball A reaches point P, ball B is projected vertically upwards from the ground. Then the balls pass each other at point Q. This is your point Q. Okay, which is 8 meters above the ground. Okay, now calculate the speed at which ball B was projected. How do we then go about this one? So in this case, I've got all the information that I need about ball A, but I don't have any information about ball B. So how am I going to then calculate the velocity of ball B? So what I can do here is I can calculate it using whatever that I have from ball B. First things first, I can check the time. What time does it take for ball B to get to this point here, Q? Okay, and then I can use the time to then calculate whatever the velocity of ball B is. Okay, so how do I go? I can say delta Y is equals to VI delta T plus your 1 over 2 A delta T squared. Okay, now this is 8 meters above the ground. Okay, remember 8 meters above the ground. This ball here that we're talking about it's coming down this. Okay, so how long does it takes for it to get to that point? Okay, that's one question that you should be asking yourself, and then the rest is going to just fall into place. All right, okay, so we set that minus 8 because we are going down. Okay, so then it's going to be equals to our VI is 20 meters because we are drawing it out, and then delta T plus 1 over 2 minus 9.8 and delta T squared. Okay, so then you can use this here to get your answer. You're going to have minus 8 equals to 20 delta T well, I can just do it like so. You're gonna have 4.9 delta t squared, and then minus 20 delta t, and then minus 8 equals to 0. Okay. But now I'm realizing that this here is not going to give me the time that I need. Okay. So now I need the time, because look at this. So when ball A was here, this is the time ball B is being drawn. But now this time here that I'll get, it's going to be the time it takes for ball B to travel all this way until Q. Okay, and we're not looking for that. We're just looking for time for ball A from this point to this point. So that means we're not going to use these numbers that we used here. So what we need to use then is, what was the velocity of ball A when it was here? It was 6.87, and then we can then calculate the time. Okay, so that means what we can do here is we do it like so. You have your 8 here, minus 8 equals to your VI is going to be minus 6.87 delta t, then plus 1 over 2 minus 9.8 delta t squared. So now you've got this now. So once you've got this time it took for ball A to move from P to Q should be the same time as the time it took ball B to move from here, the ground, until Q. And then it's what's going to allow us to calculate. So that means what I'm saying here, the delta t for A from P to Q should be equal to the delta t for B from ground to Q. Okay, it should be the same because they pass each other. So we need to know what time is that. Okay, then you can just use your quadratic formula. Then once you're here, you're gonna have your 4.9 delta t, and then plus your 6.87 delta t minus 8 equals to 0. Then when you apply your quadratic formula here, what do we get? Okay, from my calculator, and I'm getting 0.75 seconds. Okay, so now this is the time it takes for ball A to move from this point to here. Okay, so then what I'm gonna do is just come here. Then what I'm gonna do is, we are saying here delta y for A at this point is equal to delta y for B. Okay, this is what we are saying, because this is point Q. This is point Q. If you look from this diagram, they meet at point Q. Okay, and from here they say ball A reaches point P. When we are at point P, ball B is projected vertically upwards. And when it's projected, and then we pass each other here. So when this is here, ball A is here, ball B is at the ground. Then they get projected, and then they meet. Right? So that's why we're using the time for ball A. So then, once you've got this here, you've got the time, which is 0.75. You can then go check for B. So we can say delta y for B is equal to VI delta t plus 1 over 2a delta t squared. So now we've got the time. What are we looking for? We're looking for VI. VI is what we don't have. Okay? And then what is your delta y here? So in this case, we are going upwards. Okay, ball B is going upwards. So if ball B is going upwards at this point, we're going to have a positive here, a positive 8. Then it's going to be VI is what we're looking for. Time is 0.75 plus 1 over 2 minus 9.8, because the acceleration is always going to be pointing downwards. And then you're going to have your 0.75 again. Okay, and then you can then play around with this here. Let me just do it like so. So we're gonna have 8 VI 0.75, and then you have minus 4.9 here, all times, you can actually, instead of doing it like so, can I just say plus 1/2 9.8 0.75 squared, or VI 0.75. So I just took whatever, I took this thing here, I just took it to the other side, so don't worry. So then you can then just punch your calculator once you are here, and then you get your final answer. And for me, this is what I'm getting 14.34 meters per second. Okay, this is what I've got now, and then this is your final answer for this question. And then for the last question here, what do we have? The last question, they're saying, on the same set of axes, sketch the position versus time graph for pole A and pole B for the time pole A was projected until it reached point Q, and then take the ground as the 0 position. Label the graph for pole A and pole B as A and B respectively. Then they are telling us what to indicate. So the time taken for pole A to reach point P, okay, and then the height of point P, and then we also need point Q, the height of point Q. So what you need here for position time graphs, it's pretty much easy. Okay, so what you usually do is this. So you're going to, and the last question, so you're just going to follow the path of the ball as is. Okay, so we can have something like so. So if we're taking ball A, for instance, we know that the trajectory for point A just moves like so until point P. Okay, something like this. Okay, so you can do that. So we can say here, this is your 0, it moves up, and then until it reaches point P, like so. Okay, this is what happens. So if we were to label it, we've got a 0 here, we've got your 20 here that we calculated, even though they said they don't need it, but we have it. And then here you're going to have your 18, which is your point P. Okay, this is your point P here. Okay, and then you can have the time for point P. For point P, you had 2 point, was it 2 point, how much? What was the 2.74? Okay, 2.74 seconds for point P. Okay, this is what they said they want. Let me just see if they said they want from until that point. Okay, they saw this, they want until Q, and then you can then extend this until Q, because it just goes. It's not a straight line. I'd like to put it like so. Okay, this is point Q. You'd have your Q here for this ball, and then here, that means for point Q, you have what? You have your 8. Okay, this is for just ball A. So you have your A here. Then for B, ball B, we start moving from this point here because it was projected when ball A was at P. And then we just, that means we're just gonna then just move until it converges at the same point, because the side is gonna be the same time when they reach here. So then you can just say 2.74, you add this time here, and then you're going to get it. But this is what they said they need. So you can then verify if you've got everything. You've got the height of point Q, you've got the height of point P, and then you've got the time taken for point A to reach point P. Okay, this is basically what you have here. Okay, coolies, let's move to another question. So we have question 4. So here the ball of ball A and ball B move towards each other along the horizontal surface. Ball B has a mass of 0.3 kg and an initial speed of 15 meters per second. Then the balls collide. So here the vector shown representing the change in momentum for ball A. Ignore effects of friction. Okay, so first question, state the principle of conservation of momentum. It works. So what's going to happen here? So what is this principle? I'm not going to state it, but I can state it for you. So here we're saying the total linear momentum in a isolated system remains constant. Okay, so what are we saying? We're saying if we have momentum or a system, your delta pi, all initial momentum, should be equals to all final momentum. So the total momentum in an isolated system remains constant. That's what we are saying. It does not change. Okay, the velocities will change whatsoever, but at the end of the day, your initial momentum here and your final momentum should be equals. So now once you've summed all of it, okay, once you've summed all of it, so that's what you have. And then for 4.2, what was the initial direction of ball A? Choose from left or right. Okay, so here you've got the vector diagram. So what you can do to actually determine your position here or your direction here, you can use a vector diagram. Okay, because you've already got this vector diagram here. So from what we know, when you're drawing vector diagrams with regards to your your head to tail, is it tail to head? Okay, tail to head. So we know that this one here, your change in momentum is going to start at the head of the initial momentum. Okay, what does this mean? It means you would have had something that looks like so. This is going to be your head. This is going to be your head. Here, you would have had something like so. This would have been your PI. And then your change in momentum starts at the head of the PI here. That's it. So then once you've got this, what does that mean then? It means that your initial momentum is going to the right side. And that means your ball or your initial ball, your ball A is actually also going to the right side. You are just here purely using what? You're purely using your vector diagram, because there's nothing else that you can use here to actually determine this. Okay, then 4.3, they're asking us here, calculate the velocity of ball B after collision. Okay, so what are we going to do here? We're going to use this formula that I just gave you at the top. So we're just going to say P I should be equals to all PF. What does this mean? This means that the momentum, all momentum for ball A, we're going to have momentum for ball A plus momentum for ball B, which is your initial momentum, should be equals to your momentum for ball A plus your momentum for ball B again, which is your final. This is what this means. Okay, now we don't have information about ball B. We don't have any information. Oh, we do have information about ball B, which is your mass here and your initial speed. We are happy about that. Okay, initial. So for ball B, we can say initially, this is going to be a PA, initial momentum for ball A. And then plus for ball B, we're going to have your mass, which is your 0.3 times 15, which is your velocity here. Okay, now, and then this is going to be equals to PAF, we don't have, plus PB, we also don't have PB. PBF. We don't have this. So let me just use another color to just put contrast. Okay, we are sitting here, but we do have the change in momentum for ball A here. We do have the change in momentum for ball A. Okay, so now from this vector diagram again, we have said that the PI is going that direction to the right. But then your final momentum, you can see, is pointing the opposite direction. So it means you have what? You have your PF here, also pointing this direction. This is going to be your PF, like so. Okay? This is for just ball A. Okay? And then we said that again, ball A and ball A, we said is going this side. This is ball A to the right. So that means your ball B is going to the left, because here we said that they are going in opposite directions. Okay, that's also one of the things to know. Then let's go back to our question and see where we are sitting. Okay, which information do we have, and how can we manipulate this information so that we have what we need? Okay, right. So now I've got this here. PLA for A, I've got this is A, initial, and your final. So if I can say the change in momentum for A is going to be PAF minus PAI. This is the change in momentum for just ball A. So from this what I've written here, I can rearrange it so that I have the momentum, or so that I have the change in momentum. Let's paste it here. Okay, so that means I can just take, let's do it like so. We can say 0.3 times 15, and then is equals to your PAF minus your PAI. Already we can see that this is the change in momentum, then plus your PPF. Or we can take this PPF to the other side also. Let's just take it on the next line. So we're going to have your 0.3, 15 minus PPF equals to PAF minus PAI. So now this one is the change in momentum. We know for a fact. So it means what we can do, we can just substitute it with whatever the change in momentum was, which is we have here 2.4. Okay, we've got 2.4. So we can say 0.3, 15 minus PPF equals to 2.4. This is what you have. Okay, and then we can carry on further, and then we calculate the actual answer. Because once we are here, let me just carry on and say just 4.5 minus here, this is going to be M for ball B. What is ball B? For ball B, we have this, okay, which is your 0.3. It's going to be 0.3, then your V, then equals to your 2.4. This is what you have here. Okay, we can just manipulate this. We say 4.5 minus 2.4 is equals to 0.3 V. And then I'm going to have my 2.1 equals to 0.3 V. Divide by 0.3. 0.3. Then V, I'm going to have 7 meters per second. This is what I end up with. Okay? And then that's it for this question. You've got the velocity of ball B here. Okay, let's see then what does the next question hold for us. So question 5. This was question 4. Question 5, we have work energy and power. So here they're saying the block of mass m kg moves along a rough horizontal surface while experiencing constant frictional force of 3 newtons. It passes point X with a speed of 8 meters per second and reaches a point Y with a speed of Vy. Point Y is 4 meters to the right of the track. Using energy principles only, show that Vy squared is actually given by Vy squared equals to 64 minus 24m. 5.1. So here, first thing first to note is that you have what they said they want, energy principles only. That's a big note that you need to know. Okay, what does energy principles say? Say here, work done by a non-conservative force is equal to the change in kinetic energy. So what is the non-conservative force that we have here? The only force that is mentioned here is this constant frictional force of 3 newtons. Okay, so that means the work done by this force then is going to be your F delta, this is Fk delta x cos theta. Then it's going to be equals to 1 over 2 m, and then Vf, because we're only dealing with this, then Vi squared, like so. This is your change in momentum. Okay, so your F here, Fk is 3 newtons. We have 3 newtons. And then our displacement is 4. Then we're going to have a 4 here. Then cos our theta is going to be 180 because we are dealing with your frictional force, which is doing negative work. Then equals to 1 over 2. This is your m. What is the final velocity here? Final velocity is actually Vy squared, which is what we are looking for at this point here. And then your V initial is 8, which is going to be minus 8 squared, like so. So then once you've got this thing set up like this, you now actually have your answer. Okay, because you're going to have a minus 12 here, and then equals to 1 over 2 m, and then you have V squared, Vy squared minus 64. So then you can divide both sides by 1 over 2 m, even this side, 1 over 2 m. So when you have this, and then you're going to have your minus 24. Yes, minus 24 over m, like this, and then you're going to have your Vy squared minus 64. This is what you have already. This is your final answer here. So then you can say Vy squared, I'm going to take 64 to the other side, so then it's going to be positive, then minus 24 over m, and which is what they wanted here. Okay, so we have proven that. We've gotten the 3 free marks. And then here they're asking us the block then moves up an incline that is at an angle of 30 degrees with the horizontal. The block experiences a constant frictional force of 2 newtons as it moves a distance of 5.03 meters up the incline and comes to rest at point P. Now they're saying again, using energy principles only, calculate the mass of the block. Energy principles only again, right? So let me just remove this one instead. So from a free body diagram, if you can do a free body diagram for this part, we can say you're going to have your weight here, you're going to have your normal force, and then you're going to have what? You're going to have your frictional force. Okay, but now since this is an inclined we're going to have what? We're going to have here our delta, not our delta, our actual FG perpendicular, FG perpendicular, and then you're going to have your FG parallel. So we can already see that we have two forces here that are going to actually play or make a contribution to our work. Okay, this is what is going to happen here. So now let's see. Okay, so then we can then say again, work done by non-conservative force equals to the change in kinetic energy plus the change in potential energy. So now why am I introducing potential energy? It's because now we can have a height. We know that potential energy, we know that is equals to mgh. And this is moving up an incline. So we're going to have a height. All right. So now, again, let me ask you a silly question. Is gravity a non-conservative force? So when we have this work here done, are we going to add gravity, or are we going to add a component of gravity into that? Okay, the answer is no. Gravity is a conservative force. Okay, so that means when you get here, you're still going to have what? You still going to have your work done by your FK. Then going to have x like so, cos theta equals to your 1 over 2 mvf squared minus vi squared, then plus mg, then hf minus hi. Okay, this is your change in potential energy. This is when you didn't have this, it's pretty much easy for you. You have 2 newtons as your force here, 2 newtons, but now we need to calculate the height first. So height, we can say sine theta is equals to your opposite over hypotenuse. Your opposite is going to be your height. So it means you have your sine 30, your opposite is what we are looking for, and then your hypotenuse side is your 5.03. You have your 5.03. So it means you're going to have your height as 5.03 sine 30. And then what do we get from this one here? So it's going to be 5.03 divided by 2. It's going to be 2.515. So it means then when you then have, you're going to have maybe a track that looks like so. This is going to be 5.03. Then your height is going to be 2.515, like so. Then this is your 30 here. Okay, so now I can then carry on and say F is 2. I have 2. Fk is 2. So 2. And then my delta here for this force is going to be 5.03. And then my cos is going to be still cos 180. Then equals to 1 over 2 m. I don't have m. But now, when I get to this point, we have Vf. Vf here, we did calculate it as Vy squared. Then minus Vi is going to be what? Let's check the diagram again. Actually, Vi here, because we're moving from this point to this point. So your Vi is going to be your Vy. Vi is going to be your Vy. And then your Vf is going to be 0 because it comes to rest. They said it comes to rest. So that means when we come back here, we're going to say 0 minus Vy squared, like so. Okay, and then plus your mg 9.8. Your height here, your final height is 2.515. 515, then minus 0, because we start from the ground up. Okay, so we can just take this part here to the next page. So when we then put it here, now it's a matter of just manipulating what we have here. So let's manipulate it and see what do we get. So we can say here, just so that we simplify things first. So we're gonna have a 10.6, a minus 10.6, and then equals to 1/2 m minus, and then we're going to take whatever we had for our y, 64 minus 24 over m. 64 minus 24 divided by m, like so. Okay, this is what we have, and then we can add the rest. So this is going to be 2 times 2.5 times 9.8. We have 24.647 m. This is what we have. So you can just see from this that it's a matter of just manipulating this. We can then say minus 10.6 equals to, this is gonna be minus 64 plus 24 over m plus 24.647 m again. And then we can just carry on with this minus 10.6. Let me just manipulate it. Okay, this is what I get from manipulating this. You can see that here I made a mistake. So this is supposed to be 0.6, 0.6, and then 0.6 here. Then it's just gonna end up with 3 kg as is. Okay, then you have answered all the questions. Okay, that's it.